Hey everybody, it's Mr. Calloway here with my lesson on weather patterns. So I'm here to help you understand air masses in the United States and North America and the way that those different air masses come together to create fronts and the weather that's associated with them. So let's get started on the lesson. This is your lesson on weather patterns. Corresponds with chapter 13, lesson 2 of our text that we've been using in class. This is a picture of a weather map from some time back. The main system that we see in the middle of this weather map is this giant low pressure system in the center of the map. Coming off of that, going up here to the north, we see what is going to be called a warm front. And we have a cold front coming down this way, and that turns into a stationary front as it comes across here. Each one of these lines on the map represents an area of equal pressure. So as I go across these lines, I'm going from an area of high pressure out here where I see the H's to an area of low pressure down here. So the wind is going to be blowing, as I have stated before in class, always going from an area of high to low. So it's going to be this air is coming down, this air is going up. So there's wind blowing across these lines, perpendicular to those lines, everywhere that you see them on the map. So as we get things started, let's think about this bell ringer. How would you describe the air you are breathing right now? So think about where you are, whether you're at home or in the car, or wherever you're listening to this lecture or watching this lecture. How would you describe that air? Is it warm or cool? It's humid or dry? Is it stale, sweet, or salty? That may not be the way that you would normally describe air, but something that I want you to think about right now. So the air you're breathing right now was hundreds of miles away yesterday, traveling across our country. So what you're breathing came from well across the country. And hopefully by the time we're done with this, you'll be able to answer that next question. Do you know how or why air moves from one place to another? If you want to write that down, it'd probably be a good idea. It's not something that I'm going to check to see if that's in your notebook. So our objectives as we go through this lesson are going to be for you to learn how to explain cyclones and anticyclones and how they affect weather. You should be able to identify the 4 kinds of air masses that influence weather in the United States. You should be able to describe 4 types of major fronts and explain how fronts cause weather changes. You should also be able to describe the formation of thunderstorms, tornadoes, and hurricanes, describe the characteristics of those types of storms, and explain how to stay safe during severe weather. So let's get started talking about that first subject that we want to talk about, and that's going to be high and low pressure systems. A cyclone is an area that has a lower pressure than the surrounding areas do. So down at the bottom of the screen, you can see a cyclone depicted. So it's a low pressure system. That means that the air in that place would be rising. So it'd be coming out of the screen towards us with the view that we have. And the air on the outside is going to be being pulled in from higher pressure areas. And we call that a cyclone, that mostly because of the way that it is spinning. It is right next to a high pressure system that we're going to call an anticyclone. So the high pressure system air is going down, so into the screen as you're looking at it right now, goes down to the screen and then spreads out in the pattern that you see as the arrows spin off in a clockwise direction for the anticyclone. This is another depiction of those 2 things, adding a little bit more information. So it should look fairly familiar, especially with the big black text at the top, reminding you that it is a convection cell. The convection cell has 2 different parts. On one side, we're going to have the anticyclone over here on the right, where the high pressure is pushing the air down. And on the left, we have the cyclone, the low pressure system, where the less dense air is rising. So the low pressure system is going to be where the air is slightly warmer and less dense. That's what allows it to rise. with the high pressure system on the right, the anticyclone that's going to have the cooler air as it sinks. The sun is the major driving factor in all of this. It's what drives everything that's happening on our planet with regard to weather. So it's making all of the air move from one place to another. The radiant energy coming from the sun comes down and warms the ground, and then that ground is in contact with the air. So through the process of conduction, it warms the air and it travels across the ground, warming the air. It gets warmer and starts to rise. As we have recently learned in class, that warmer air is going to be able to hold more moisture. So that warm, moist air is going to rise up into the atmosphere where it's going to cool off, because we know in the troposphere, as you go up in elevation, things get colder. The air is going to cool off, and condensation is going to take effect because the air is just not going to be able to hold it anymore. So the humidity gets past that dew point where water droplets are going to form, clouds are going to form, and then that whole process just starts to, or continues the way that it was. And now we have cooler, more dense air up in the sky. It's going to move to a new location again and begin to sink at the high pressure area. And that keeps things moving across our country all of the time. One more depiction of that to help us understand it just slightly differently is this drawing that we have. So low pressure systems are the ones where the warm, moist air is rising. The high pressure system is where the cooler, more dense air is sinking. In those situations, though, one of the things that can make this a little confusing sometimes is the high pressure systems where we have denser, cooler air is also going to be equated with sunny days, because in those situations, we don't have clouds. It's the low pressure system that allows the warm, moist air to rise, that less dense air rising. And when it gets up into the atmosphere, condensation takes place to form the clouds. So I hope you don't get those two things confused. You need to try to make sure that you remember that the clouds are formed by the warm, moist air rising and then condensation taking place in the cooler upper parts of the atmosphere. So a low pressure system is a large body of circulating air with low pressure in the center and higher pressure on the outside. I think you'll find that as one of the first answer on your outline for your lesson outline. Air moves from high pressure to low pressure. We've stated that over and over again in class, that everything moves from a high concentration to a lower concentration in nature. And in a low pressure system, air is going to move away from the outside of the system. So remember, the low pressure, the air is rising in the center, so it's going to be pulling in air from the outside, just like when we talked about our convection current with our ocean breezes and our land breezes. The warm air is rising, pulling the air in from the other area from where the higher pressure is. Our next one is the high pressure system, so it's going to be exactly the opposite of the low pressure system. So high pressure system, the air is dropping, the cooler, more dense air is going to be dropping. It comes down to the ground and then it's going to go out. So a high pressure system is a large body of circulating air with high pressure in the center and low pressure on the outside of the system. So again, we're going to move from high to low concentrations. So high pressure air in the center sinks and moves towards the low pressure areas that are outside of it. And like I stated earlier, that's going to produce our clear, sunny sky. So that's why we see the sunshine up here. Again, low pressure, warm air rises, condensation takes place and forms clouds. High pressure, the relatively speaking cooler air, more dense, sinks, but we get nice sunny days like we have had for the past several days when I'm putting this together. The next thing I want to share with you is information about air masses. Air masses are large bodies of air where temperature and moisture content are constant or the same throughout, and form when a high pressure system lingers in one area for more than a few days. We have two main types of air masses. They're going to be hot and cold air masses. As you might imagine, the cold air masses are going to come from the north in the United States, and the warm air masses are going to come from the south. So the colder weather that we get in the United States in the winter is going to come from the polar regions or from Canada, and the warmer air that we get is going to come from both the west coast, off the coast of the United States, up from Mexico, and then from the Gulf of Mexico. Here's a diagram that indicates all of those for us. So we have several things to talk about on here. Four main types of air masses that we want to make sure that we understand. On the top part of the diagram, you can see three blue air masses, blue representing the fact that they're going to be colder. If they are air masses that form over water, we are going to call them maritime air masses. And you can see we have two of those, one coming from the west and one coming from the east, both off of the continental part of North America. So we're going to call them maritime polar air masses. So one coming from that area up towards Alaska on the western side, and then an area over there close to Nova Scotia and Canada on the eastern side. The final air mass that we have up there is formed over the continent. Because it forms over the continent, you should have an idea that it's going to be a drier air mass than the air masses that form over the ocean, because there's not as much moisture for it to carry. All of them are cold, so they're not going to hold nearly as much water vapor as the air masses that we're going to talk about in a second that you can see on the bottom of the diagram. But that central air mass in the top, labeled CP, is going to be a continental polar air mass. So it's going to be cold and dry. While the MP air masses, the maritime polar air masses, are going to be cold and wet. And then in contrast to those, we have the three air masses that you see at the bottom. So we have maritime tropical air masses, both off of the west coast, coming up from Baja Peninsula of Mexico, and then from the Caribbean Sea off to the east or southeast of the United States. Those are represented with the MT symbol. And then you see a smaller air mass that's coming from central Mexico that's going to sometimes come up into the United States, which is going to be a hot, dry air mass, that continental tropical. So once again, continental air masses are going to be drier than the maritime air masses, and tropical air masses are definitely going to be warmer than the polar air masses. So changes in weather are caused by the movement of these air masses that we were talking about. And where those air masses run into each other, we are going to label it as a front. We have four different types of air masses or fronts that I want to talk to you about. The first one would be a cold front. A cold front forms where cold air moves under warm air, which is less dense, and then it pushes the warm air up. From your prior knowledge, you should understand at that point the warm air is definitely it has the ability to hold more moisture. As it rises, condensation is going to form. And in these situations, it's often going to bring severe storms and cooler temperatures. So we have the warm air rising very rapidly in some situations, forming very large clouds, big thunderstorm clouds. And as that front pushes on out, since it's cold air that is pushing it, we're going to have a cooler air behind it. The next type of front is going to be a warm front. This is also going to bring precipitation at the front line because the warm air, as we know from our prior knowledge, is going to be less dense than the colder air that it's pushing out. So it's going to ride over the cold air, pushing it along out of the way. But also at the same time, that warm air is still kind of rising. It's being, as it goes over the top of the cold air mass, that's going to cause some condensation to take place, and precipitation is going to occur. But this usually are not violent storms like we get with cold fronts. It's also going to bring warmer temperatures behind it because, again, it's the warm air mass that's pushing the cold air out of the way. So this diagram helps us understand that a little bit. So we have a diagram of a cold front on the left. So you can see the cold air masses coming in, forcing the warm air to rise and causing these large thunderstorm clouds to form, dropping lots of rain. When this happens very quickly, that air rises very fast, that's when we can have more severe weather like tornadoes that we'll talk about later. But also it gives the air the ability to lift that precipitation back up, get it high into the atmosphere, and start to cause the formation of hail. As the water droplets rise, they go up to where it's cold and freeze and come back down. That warm air continues to pull it up, and that process takes place over and over and over again, forming hail. Eventually it gets too heavy and it comes crashing down to earth. The warm front moving the same direction from left to right on our screen, but this time the warm air is moving over the cold air, pushing it out of the way. The warm air rises much more gracefully, usually will give us just a really nice light rain as it's moving out, and we have nice warm air in place as it gets out of the way. Two more fronts to talk about. The first one is going to be an occluded front. An occluded front forms when warm air mass is caught between two colder air masses. An occluded front has cool temperatures and large amounts of rain and snow often. We'll see a diagram of that in just a second. And we also have stationary fronts. So stationary fronts form when the boundary between two air masses stalls. And this often brings cloudy skies and light rain, wet weather. So here's a diagram to go along with these. So the occluded front first, everything is moving to the right again, direction of front, as you can see. The arrow is pointing down here at the bottom. So everything is moving to the right. Two cold air masses. So this cold air mass is running into the second cold air mass, trapping the warm air mass above it. So warm air is rising. Again, it holds more moisture. Condensation is going to take place. So that, and then precipitation is going to follow that. Depending on how cold the air is underneath it, we're going to get snow or maybe even freezing rain, depending on the situation as it moves out of the way. Stationary fronts are a little bit different. So on this one, you can see we don't have an arrow showing direction at the bottom because we have air masses that are moving in opposite directions. So we have warm air coming in from the right and cold air coming in from the left. So they're running into each other. And once again, we have that warm air rising, condensation forming, precipitation following that. So all four types of air masses that we went over, cold fronts, warm fronts, occluded fronts, and stationary fronts are going to give us regularly give us some type of precipitation. The ones that are going to produce the most severe weather are going to be the cold fronts, and that's where we're going to get our thunderstorms. Thunderstorms develop around low pressure systems. They provide warm temperatures. There's a lot of moisture in the air, usually because the air is warmer, and the rising air is going to rise rapidly, creating the large clouds and form thunderstorms. In those thunderstorms, of course, we're going to have lightning because you can't have thunder without lightning. Lightning is an electric discharge that occurs between positively charged area and negatively charged area. They are very active electrically. So This goes along with the same statement that I've made in class several times, that we always move from an area of high concentration to an area of low concentration. And in this particular instance, the area of high concentration is going to be high concentration of electrons, that negative charge. When it gets too large and the difference becomes too big, it's going to jump to the area that doesn't have the electrons, that the area that's positively charged, and create lightning. When that occurs, the area that the lightning goes through gets superheated super fast, and then it also cools off super fast. So again, from your prior knowledge, you should have some understanding about what happens to matter when it gets heated. It is going to expand because of thermal expansion. So when lightning goes through the air, it heats it up really fast. The molecules get really excited and spread out really quickly, and then they cool off really quickly again, coming back together and creating what we know as thunder. So thunder is the sound that results from the rapid expansion of the air along that lightning strike. Thunderstorms have three main stages that we want to be familiar with. The first stage is called the cumulus stage. So this is the stage of the thunderstorm that starts with cloud formation and that updraft, so right along that cold front. The matured stage of the thunderstorm is going to contain heavy winds and rain and lightning. So that's the exciting part that all of our animals don't like. And then finally, when the thunderstorm starts to calm down and the wind and rain start to subside, we're going to call that the dissipation stage of the thunderstorm. So sometimes those thunderstorms become even more violent. So, and they have what would be considered a spinning column of air in them that's going to form into a tornado. So it's really high speed wind with a low central pressure, very much like a hurricane that we'll talk about shortly. But it doesn't actually become a tornado until it touches the ground. Tornadoes are most common in the central part of the United States in the plains. This area has been named Tornado Alley for the how often these tornadoes occur there. Here, strong frontal boundaries are formed when the cold polar air comes down from the north, from Canada area, and meets the warm tropical air masses that are coming up from the south. So when you have a higher contrast or a difference in those temperatures, it creates a bigger difference in the pressure. So it allows for the rapid uplift of the really warm air and can create these very violent storms. Here's some pictures to help us understand that. They're a little blurry, and I apologize for that. Number one says, the wind is moving in two directions, causing a layer of air in the middle to begin to spin like a roll of toilet paper. And it usually is horizontal at that point, parallel to the ground. The spinning column is turned vertical position by strong updraft. So at that cold front, as the warm air is being pulled up, it will take that horizontal column of air that was rolling and start to turn it up on its end. And then that spinning column of air moves to the bottom of the cumulonimbus cloud and forms a funnel cloud. And if that continues, that funnel cloud can come down to the ground and touch the ground. And only at that time is it officially called a tornado. Hurricanes are the other type of really violent weather that we can have on our planet. They begin when a group of thunderstorms come together and the winds traveling in two separate directions meet and cause the storm to start to spin. Hurricane is an intense tropical storm and can have winds up to, I guess it becomes a hurricane when those winds start to exceed 119 kilometers per hour. Hurricanes typically form in the late summer over warm tropical oceans because that's their source of energy. Water is evaporating out of that warm tropical ocean and then rising up into the atmosphere. As it rises and starts to condense, it loses its energy, so it gives off energy in the process of condensation, leaving latent energy in the air, which gives the air more energy to hold more moisture, so it kind of feeds itself as it brings that moisture up. As long as the hurricane is over warm tropical water, it will continue to grow. It's not until it moves over land or global winds carry it into an area where the water is not as warm that it starts to lose its energy and slowly fade away. So here's a diagram helping us understand this a little bit. It's a cross-section of a hurricane. So we can see in the center of the hurricane, there is actually a little bit of a downdraft in the eye. So it's an area of extremely low pressure that most of the hurricane is. So surrounding the eye is the eye wall. It's a group of cumulonimbus clouds that produce heavy rains and strong winds. The winds can reach up to 300 kilometers per hour. That has happened and is definitely the strongest part of the hurricane. The center of the hurricane is the eye, or the core, of warm, relatively calm air, low pressure, and light winds. So low pressure is going to tell us that the air is going to be rising. So we have updraft. You can see they're depicting downdrafts in the diagram too. So we've got as warm air is rising, the cold air is sinking, creating these cumulonimbus clouds, just like at a cold front. Below the eye wall, spiraling bands of cloud called rain bands circle the outside. The rain bands produce heavy rains and high winds. Within the area of the hurricane, wind speeds within that area, wind speeds decrease as the distance from the eye wall increases. So the farther out you get, the lighter the winds are going to be. Blizzards are our final storm that we want to talk about. They are severe winter storms characterized by freezing temperatures and strong winds and blowing snow. So they too are going to occur at an area of a front because you're going to have the contrast between the warm, moist air and the cold air, causing the warm, moist air to rise. Blowing winds is going to indicate to us that we have a large difference in pressure. So remember, we're always going from a area of high pressure to an area of low pressure. The bigger the difference between those two, the stronger that wind is going to blow. And finally, just a quick note about the National Weather Service. We've been using that website in class to look at the current weather conditions every day. They are responsible for letting everybody in the country know when storms are coming. When they're expecting a storm to come, some type of severe weather situation, they will put out a watch. And when that weather is already occurring, when we know we have a tornado on the ground or we know that there's a blizzard occurring, they will issue a warning saying, hey, this is happening. You should stay away from the area. Well, that's all the information that I have for you for this lesson. Thank you for your support and thank you for listening. And I want to encourage you to go to my YouTube channel as I have and look for my playlist that I have for weather and weather instruments that's out there. I've listed the link here, but I don't know that you'll be able to click on it in this video. But you should be able to find the link to that on the website somewhere in the assignment or the lesson. I know I have it on your class webpage, so click on that, look for the playlist that's going to have weather and weather instruments in it, and I'll have some additional videos on there, some other folks' videos that you might be able to use to help yourself understand things a little bit better. So I appreciate you listening. Please ask some questions if you have them. I know I won't be here next week, but we will work that out. Again, I'll see you next time.